Good morning, good afternoon, or good evening, and welcome to our video class for today. Happy Friday, or Saturday or Sunday, whenever you're watching this. Today we are going to be talking about adding and subtracting polynomials. Okay, so I'm going to go right from the lecture notes, so you can follow along there, or you can just watch along with me. Okay, let's get started. Okay, so today we're talking about polynomials, and when we're talking about polynomials, poly meaning, many, we're talking about kind of a collection of monomials, mono meaning one. So in this case, we see that there are there's 4 different monomials in this equation, all right? Now, when we have a polynomial, you'll notice that the polynomials are usually, they're always written in decreasing order, where the exponent of your variable gets smaller. So we start with the largest exponent and we go to the smallest exponent, okay? Now, if you have more than one variable, like in this case right here, 6x to the fourth, y to the third, and you're looking at the degree. So the degree of the term is what the exponent value is. So the degree of this term right here, 5x squared, the degree is 2. So we're looking at the numeric value of that exponent. If there is more than one variable, the degree is both of those added together. So in this case, 6x to the fourth, y to the third has a degree of 7 because we add together both of those exponents, okay? So if we're looking at the degree of the polynomial, so you either have the degree of the term, where you're looking at just one term independently, like this one. So the degree of this term is 3. The degree of this term is 2. The degree of this term is 1. Okay? So you can look at the degree of the term individually, or we can look at the degree of the whole polynomial. Okay? So remember, this whole thing together is a polynomial. And if you're looking at the degree of the polynomial, as it says right here, the degree of the polynomial, we're looking at the largest degree. Okay, so we're looking at the largest degree. So in this case, we have 7x to the fourth plus 3x to the third minus 2x squared plus 2. So the largest degree here is in this term, 7x to the fourth. So the degree of the polynomial is 4, because the largest non-zero term is 4. Okay, so we're looking at the value of the exponent. All right. Now, we've done some work with a lot of work with one type of polynomial. Okay. Let's see. Polynomials that have a degree of 1, 2, and 3, they all have special names. Okay. So if the polynomial is to the degree of 1, it's a linear polynomial. It's a first degree. Okay, so here are some examples. 3x plus 7 or 2x. So these are linear or first degree polynomials. They are polynomials to the first degree. Okay. Now, if we have a polynomial to the second degree, that is a quadratic polynomial. Okay. So that means that your largest exponent value is going to be 2, like 8x squared minus 5x plus 2, okay, or x squared minus 4. Okay, these are polynomials to the second degree, or quadratic polynomials. Okay. Now, finally, if a polynomial is to the third degree, it is a cubic, or a third degree polynomial. Okay, and all that means is that we have a variable to the third the third degree. So 4x cubed plus 2x squared minus 6x plus 5. That's one example here. Polynomial to the third degree. Or something like this. Negative 6x cubed plus x. Okay, remember that what we're looking at is the largest degree. Okay, that's going to name your polynomial. And only polynomials to, only polynomials to the first, second, and third degree have special names. Okay, the other ones you just say it's a polynomial to the degree of 4, or a polynomial to the degree of 7 or something. Okay, so if we look at these polynomials below, we can use the words linear, quadratic, cubic, polynomial, degree, one variable, and two variables to describe them. Okay, so if we look at this first one here, 5x squared minus 3x plus 7, we want to describe this polynomial. So if I look up here, I can see that a polynomial, this one is, the largest value is to the second degree, the largest term. So we know that this is a second degree polynomial, which is a quadratic. So I could say that this is a second degree polynomial. I'm just going to abbreviate, I'm running out of space. Or a quadratic polynomial. Okay. I can also identify that there's 1, 2, 3 terms. And let's see, how many variables do we have? We have x, and no variable. So this is a polynomial with one variable. Okay. All right, let's look at the one down below. So again, we see that this is a second degree polynomial, which means that it is a quadratic polynomial. Okay. There are 1, 2, again, 3 terms. And let's see, x, and nothing. So we have one variable. Okay. Let's go to this one over here. Okay. Now, if we're looking at the degree of the polynomial here, these other ones, we had the degree identified just on one variable. Okay. So we look over here, automatically we can see that this is a 2 variable. Okay, because we have 2 variables. We have a and we have b. Now, we're looking at the degree of this polynomial, and we said that it's the largest degree of any non-zero term. Okay, but the other thing that we have to consider is that this term here has a 3 and a 2. Okay, so if we had a term right here, if a term contains more than one variable, remember we have to add together those exponents to determine the degree. So if we look here, we have a 3, a cubed, and we have a squared. So if we add these together, 3 plus 2, then this polynomial has a degree of 3 plus 2, which is 5. Okay. All right, so degree of 5, which means it's not linear, quadratic, or cubic. It's 2 variables. All right. I think that's all we can say on this one. Yeah. Okay, let's do one more. This one here. So again, I see that we have an m and an n, which means we have 2 variables. So it's a 2 variable. And let's figure out what degree it is. So again, this term, we have a 7, and n, if there's not something written here, we know that that means 1 because n to the first is the same as n. So we have 7 plus 1. So we have a degree of 8. Okay, so this polynomial here is a two-variable polynomial and has a degree of 8. Okay. All right, so now we know how to talk about polynomials. Okay. Now, when we're working with polynomials, we have to remember to combine like terms. Okay, just like when we're working with linear, well, I guess a linear equation is a polynomial. But when we're combining like terms, any of the terms that have the same variable raised to the same power, we can combine those. So these are both t squared. So if this is t squared, oops, and this is t squared, then we can add the coefficient. And the coefficient is the number here at the start, okay? So if these are both t squareds, then we know that we can add them together. We can add the coefficients together. So 3t squared plus 5t squared is 8t squared, okay? So the only thing we have to make sure is that our term, the variable, is the same, raised to the same power, all right? So if we look at this next one here, we have negative a to the fourth b to the third, okay? So the variable that we're looking for here is a to the fourth b to the third. Now the next one also says a to the fourth b to the third, okay? So if we have negative 8 minus 3, and these both are a to the fourth b to the third, right? Then we can combine these and we can say negative 8 minus 3 is negative 11 a to the fourth b to the third. Oh, just like that. Okay. All right, let's look at the next one. Here we have negative x to the sixth plus 7x to the sixth. Again, we have this term here, this variable, x, raised to the power of 6. This is x raised to the power of 6. So that means that we can combine these coefficients. We don't have anything here in front of the x, which means, if you remember, that it's negative 1x to the sixth, okay? So we have negative 1 plus 7, which is going to be equal to 6x to the sixth, okay? All right, take a look at these two right here. Pause the video for a moment and see if you can combine these like terms by yourself, and then come back. Okay, welcome back. So here we have a squared, so we know we can combine these two. So negative 4 plus 9 is a positive 5a squared. Okay. Next one, we have b to the third and b to the third. So we have the same variable raised to the same power. So we can combine 5 minus 8. 5 minus 8 is negative 3b to the third. Okay. All right, let's look at another one here. Here we have, this one looks kind of like a mess, huh? 4x squared minus 7x plus 3x squared minus 9x. Okay, now if you have something that's written like this, remember, first of all, we said that polynomials are going to be written from the largest degree term to the smallest degree term. So if we have x squared and we have x, we know we're going to write our x squareds first, okay? Now I see that we have x squared here and we have an x squared here. All right, so I can combine these two terms. So 4x squared plus 3x squared is going to be 7x squared, okay? Now, I also have these x's, negative 7x and negative 9x. So negative 7 minus 9 is negative 16x. Now, since this x, these are both the variable of x, but this is raised to the power of 2, and this essentially is raised to the power of 1. So we cannot combine these terms because they are not the same variable raised to the same power. Okay? Now, the same thing happens over here. Here we have 5x squared plus 2x. This is raised to the second power. This is raised to the first power. So actually, we cannot combine that anymore because they're not raised to the same power. All right? Okay, let's look at the one right underneath here. Okay, now in this one, I see that we have some x to the thirds, some x squared, and x, and just a constant. So let's say I start with my x to the thirds because I know that those have to go first, okay? So I'm gonna, for me, I like to find a way to notate these so that I know I don't forget anything. So I have negative 5x to the third minus 7x to the third, okay? So total, that would be negative 12x to the third, okay? Now I need to find my x squareds because remember they have to be written in degree order from largest to smallest. So I did my x cubes. So now let's see, here's an x squared here, but that's the only one. So we have plus 2x squared. All right. After x squared would be my x's. So here's an x and here's an x. So negative 4x minus x would be minus 5x. Okay, and finally my constant plus 5. So now I have an equation that reads negative 12x cubed plus 2x squared minus 5x plus 5. Okay. All right. Let's go to this one. Now, here we have 2t to the third w to the fifth plus 4t to the fifth w to the third. Okay, what can we do here? You're probably thinking that we can't really do anything because this t is raised to the third power. This t is raised to the fifth power. This w is raised to the fifth power, and this w is raised to the third power. So actually, even though their degree, even though their degree is 8, even though both of them have a degree of 8 because you add the exponents, these are not like terms, okay? So t to the third, w to the fifth is not the same as w to the fifth, t to the third. Those are two different terms. So again, there's nothing that we can do. That one is as simplified, as combined as it can get. Okay? Let's look at the next one. At any time when we get to one of these items, please feel free to pause and give it a try yourself, and then unpause, okay? All right, so when we look at this one, we're looking at, we have a to the 7th b squared minus 2a to the 7th b squared. Now these both have a to the 7th b squared. Both terms have the variables a to the 7th b squared. So since they both have the same variables to the same power, we can combine them. So 4 minus 2 is 2a to the 7th b squared. Okay? All right. Ooh. Now this looks a little bit ugly, doesn't it? Okay. So I'm looking through here. I want to see what I have in common. Let's see, I have a degree of 4 here. I have a degree of 4 here. Look, I've got 2 of these x squared y squareds. Okay. Oh, but look at this. This is plus 2x squared. This is minus 2x squared. So we know that those are going to cancel out, aren't they? All right. Now, okay. So let's get started here. It looks kind of messy, but we're going to start with 2x to the 4th. There were no other x to the 4ths. Okay. But I do see x to the third y, x to the third y. So negative 4x to the third y and positive x to the third y. So negative 4 plus 1, negative 3 x to the third y. And then what do I have left? Ooh, plus x y to the third. Okay, that's it there. All right, last one. Okay, so again, we're looking for the same variable to the same power. So here I have 9a to the fourth b squared. Oh, here we go. I have negative 7a to the fourth b squared. So 9 minus 7 is 2a to the fourth b squared. And then I have ab to the third, negative 5ab to the third, plus 8ab to the third. So negative 5 plus 8 is plus 3ab to the third. Okay? So the biggest thing that you need to remember is that when you're looking through these, that you're looking at the variable and the power that the variable is raised to. Because if they're not the same, like in this one, x squared and x, or t to the third w to the fifth and t to the fifth w to the third, if they're not exactly the same, you cannot combine the coefficients. Okay? All right. Now, let's see. Sometimes we're going to be adding polynomials together, okay? So when we're adding polynomials, basically we're combining the like terms, all right? Now, you remember that there's a property of addition that says if I have let's say there's a plus there. There's a property of addition and multiplication that say it doesn't matter how I add these together. So I have 4 plus 3 plus 1 plus 2. Here I have the parentheses around the 4 plus 3 and the 1 plus 2. But I could put the parentheses here and do these ones first, and my sum will be the same. Okay, so that's something that we kind of need to keep in mind here, because if we have two polynomials that are put together like this, okay, we have these two in parentheses, we have these two in parentheses. They're all addition, so we can add them all together. So what we're looking for is the like terms, okay, again. So here we have 4x squared and 6x squared. So we have 4x squared plus 6x squared. All right. Over here we have plus 3x minus 2x. Whoops. This should have been, whoops, I'm sorry. This should have been 5x. Plus 5x minus 2x. So we have plus 5x minus 2x. So then we can combine these two terms, the x squareds here, to be 10x squared, and we can combine the x's to be a positive 3x. Okay? So let's try a couple here. All right. So if I'm looking here, I see that I have x squared here and here. So 3x squared plus 6x squared is going to be 9x squared minus negative 5x plus 2x is negative 3x, and then we have negative 2 minus 7 is negative 9. Okay, so basically, since these are all combining all the way across, we can take the like terms from here and combine them. Okay, let's try another one. Why don't you go ahead and pause this and then come back to it and see if you did it correctly. Okay. All right, so we have negative 2x to the third and positive 5x to the third. So that gives us a 3x to the third. And then we have 4x minus 6x. I'm sorry, whoopsies. Oh dear. That was a big whoopsies. So we have negative 6x squared. Okay, that one's just x. Can we combine these two? No. So we have negative 6x squared. Whew, that was close. We have plus 4x. We have plus 4x here. And finally, we have our constants here. Negative 3 plus 2 is negative 1. All right, so make sure that as you're working very carefully so you don't make the same mistake that I almost did there. Okay? Okay, let's go to the next one. So pause if you will, give it a try, and then come back. All right, we have negative 5x to the third minus 4x to the third. So that's negative 9x to the third. Okay, now we're looking for x squared. I see we have an x squared here, but no x squared over here. So we have minus 8x squared. Okay, now we need to find some x's. Let's see, I have an x here, so plus x. And looking for constant numbers. We have a positive 4 and a negative 9, so that means negative 5. Okay, so that's what we got. Okay. Ooh, this one looks ugly. So go ahead and pause, give it a try, and then come back. Okay, welcome back. All right, so here, we've got a lot of stuff going on. So I see that I have an x to the third y. That's the only one. So I'm going to start with my x to the third y. Okay, I'm going to mark it so that I don't forget that I already marked that. So x to the third is going to go first, and then I see also that I have x squared, y squared, x squared, y squared. So if I have negative 5x squared y squared plus 5x squared y squared, these two are going to cancel out because negative and positive of the same coefficient is equal to 0. All right, so what else do we have here? I see plus 2xy to the third minus 4xy to the third. So that means I can combine these two, and that's going to give me minus 2xy to the third. Okay, and finally, oh, sorry, I used that one already. Finally, we have this one left, plus 7y to the fourth. Excellent. Okay, now that's addition. So basically with addition, all you have to do is combine the like terms across. Now, with subtraction, if you want to subtract polynomials, first you distribute a negative 1, and then you can combine like terms just like you did before. So what that means is if I have, I'm going to get a different color. If I have this equation, okay, 8x to the third plus 5x squared minus this part here, you think about it like I have a negative 1 right there in the front, okay? Well, just like I wrote right here, okay? So if we take that negative 1 and we distribute to each of the terms in the parentheses, then we're just adding, okay? So we have this first set of terms here, 8x to the third plus 5x squared, and then we have plus negative 6x to the third minus 2x squared, okay? So now we can just combine our like terms. So we have our x cubed here, 8x cubed minus 6x cubed, and then we have 5x squared plus negative 2x squared. Okay, so that gives us 14x to the third plus 3x squared. Okay, so let's do the same thing down here. All right, so remember we have like a negative 1 right here. So we're going to have this term still, and then we'll have minus 9x squared plus 5x minus 4. Okay, so 2x squared minus 9x squared, negative 7x squared, 4x plus 5x plus 9x, negative 7 minus 4 minus 11. Okay, take a look at the next one. Go ahead and pause, give it a try, and then come right back to it. Okay, I'm going to distribute my negative 1. Welcome back. So we have positive 7x to the third minus x plus 1. Okay, we still have this one here. So 6x to the third plus 7x to the third is 13x to the third. Negative 3x squared. We do not have an x squared over here, so we're just minus 3x squared. X is none here, but I do have a minus x here. And then we have plus 4 plus 1, so plus 5. Okay, all right. Whew. Go ahead and pause it again. Try this one out, and then unpause it. Okay, we're going to distribute our negative 1, so this will be plus 2m squared plus 7mp plus 4p squared. Okay, so m squared, so 10m squared. Okay, we have mp plus 10mp and p squared. Minus 5 plus 4 would be minus p squared. Okay. All right, last one. Give it a little pause and then come back. Now, this one looks a little bit more confusing, but don't let it trick you, okay? Okay, so negative 1, so we have negative 4x to the third y squared plus 3x squared y to the third minus, oh, not minus, plus 5xy to the fourth. Okay, so I see that first we have listed an x to the fourth y, and over here there are no x to the fourth y's. So I'm going to write, oh, not purple, 6x to the fourth y first, and then I have x to the third y squared. So plus positive 1 minus 4, so minus 3x to the third y squared. Okay, so I've gotten rid of that one. Now, switch colors again. I have x squared y to the third, x squared y to the third. Now this is negative 3, and this is positive 3. So that means that these two are going to cancel each other out. And finally, at the end here, I have a positive 5xy to the fourth. So plus 5xy to the fourth. Okay. Well, that was a lot of fun, wasn't it? Combining like terms. Really cool. Listen, on Monday, we will go over a polynomial function. Okay, and basically it's going to kind of be the same thing as combining the like terms, and then we're also going to be substituting a number into the function. Okay, so happy Friday. Sorry there were no fractions today, but have a fabulous weekend, and I'll see you on Monday. Bye.